Hey, Eagles. Um, Yesterday, we started talking about adding and subtracting using integers. And that just meant we were looking at positive and negative numbers with no decimals, no fractions. Today, we are going to be looking at how we can add and subtract rational numbers. So, today we're adding and subtracting those numbers with decimals and with fractions. So, let's dive in. We've got a few word problem examples. The first one says Samantha owes her father $7. She just got paid $5.50 for babysitting. If she gives that money to her dad, how much will she still owe him? Well, this is a word problem, so we've got to do some RDW. So let's decode what this story problem or this short story is trying to tell us, okay? So let's look at Samantha owes her father $7. Owes, that means she needs to give it to him. So that's negative. She's negative $7. Okay. And then it says that she got paid. If she's getting paid, that means that she's adding to her money. So that's positive $5.50. If she gives that money to her dad, we want to know how much will she still owe, okay? And what this tells me, if she's still going to owe some money, that maybe our answer will still end up being negative. I don't know yet though. Let's see. Okay, so what we're going to do is we're going to go ahead and draw a number line to help us because that was part of the instructions. Create an equation and number line diagram to model each answer. So I'm just going to freehand a number line here. And it's not going to be perfect, and that's okay. I'm going to place my 0 right here in the middle. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's -1, -2, -3, and so on and so forth. I'm going to finish labeling out my number line here. And then I could go positively in the other direction as well. Let's start here though. I know that she owes her father $7. So am I starting at the 0? No. I'm going to start at -7 because this is our starting point. This is what she owes. So she owes $7. So we're at -7 and she's getting paid $5.50. So we're adding $5.50. So we have -7 and we're adding a positive $5.50. So that mean I'm going to put my tail of my line here at the -7 and I'm going to move up 5.5. So I know that that's going to be 5 whole units. So I can count it out 1, 2, 3, 4, 5. And then 50 would be like halfway, right? So as I'm drawing my line, I'm going 5 units and then maybe about a half so that I'm landing in between some particular numbers. Okay. And so based on the work that we've done so far, it looks like that our answer should be between -1 and -2. Let's see if that is so. Okay. Well, what I have here is -7 plus 550. What we found out from previous work is that we could also rewrite this to think about it in a way of -7, its absolute value is 7. And the absolute value of 550 is 550. So if we find the difference of their absolute values, that will give us our sum. That was a rule that we talked about when we're adding opposite operations. We take the difference of their absolute values. So what's going to be the difference? Well, difference implies subtraction. So that means I'm subtracting 550 from 7. And how did I get that? Once again, the rule for adding opposite signs says that I can take the difference of the absolute value. Okay, so once again, the absolute value of -7 is 7. And the absolute value of 550 is 5.50 or 5 and 5 tenths. So I'm going to take the difference of their absolute values. Well, I know that 5 cannot go into 0, so I'm gonna have to unbundle a 1 here. That'll become 6, and this will become 10 tenths. 10 minus 5 gives us a difference of 5, and 6 minus 5 gives us a difference of 1. So we have a difference of $1.50. Now, here's the thing. Is this $1.50, what sign should it have? Should it have positive or should it be a negative sign? Well, remember, the integer, or in this case, the rational number with a greater absolute value determines the sign. -7 has the greater absolute value. So that means that since -7 is negative and it has the greater absolute value, then that means that my answer is also going to be negative. So my answer comes out to be -150. And that should match up with what we have on our number line. And that's what we see here. It's between -1 and -2 on the number line. So it matches up with the work we did on the number line. So then we need to go ahead and answer our question with a smart statement. How much will she still owe him? Well, -$1.50 means that that's what she still owes. This is what she owes. So we can write our smart statement. Samantha will still owe her dad $1.50. Okay, that's problem A. All right, let's look at problem B. Problem B says, at the start of a trip, a car's gas tank contains 12 gallons of gas. During the trip, the car consumes 10 and 1/8 gallons of gasoline. Excuse me. How much gasoline is left in the tank? Okay, so then let's use our RDW skills. At the start of a trip, at the start. Okay. This is how much it's in the tank. Okay, so we're positive this amount. All right. During the trip, the car consumes. Consumes means that that's what's being used. So that means we're subtracting this amount from the gallons of gas. So what does that look like? Well, if I had to make an equation for that, that would be 12 minus 10 and 1/8. We're going to come back to that equation because we want to be able to find how much is left in the tank. So first, let's go ahead and show this on a number line and get a general idea of what our answer should be. So I'm going to go ahead and start my 0 about here because I need more space since we're starting at 12. We're subtracting from 12. So I need more positive space than I do negative space. So I'm going to draw my number line where the positive side is longer than the negative side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, let's go a little bit further out. Make it long enough so we don't have the crowded. There we go. And let's label. Five, 6, 7, 8, 9, 10, 11, 12, 13. And of course, we could go back here and put negatives if we needed to. All right. Well, we're starting at 12 because that's how much gas was in the tank at the beginning. So our start is at 12. We're not starting at 0 because we have 12 gallons in the tank. So our starting point is 12 on our number line. Now we're subtracting 10 and 1/8. So that means I'm going to be moving to the left 10 and 1/8. So I'm essentially going back 10 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then about 1/8. So it's going to be somewhere maybe around here. So I'm going to start my arrow, the tail of it, here at the 12, and I'm going to move it to the left. I actually need to stop right there at that line. So drawing this little line here after we've kind of counted it out helps to ensure that we know where to stop our arrow. And so this arrow represents the minus 10 and 1/8 gallons of gas that was used on the trip. Okay, so we know that our answer based on the work we did on our number line should be somewhere maybe between this 1 and this 2, between +1, +2. Let's test this out. So we're taking 12 and we're subtracting 10 and 1/8. Well, this is a mixed number and this is a whole number. So in order to subtract, since there's a fraction involved, I have to, in order to subtract fractions, have the same denominator. So what I want to do is I want to rewrite this whole number as a fraction with a denominator of 8. So I'm making an equivalent fraction with a denominator of 8. Well, the way that I can do that is I can think of, well, how many eighths would it take to make 12 wholes? So essentially what I'm doing is I'm multiplying 12 times 8, and I'm doing that work down here. So that's 8 times 2, which gives me 16. 8 times 1 gives me 8, and then one more makes 9. So there are 96 eighths in 12. So I'm going to rewrite this as 96 eighths minus. Now, this 10 and 1/8, I don't want it as a mixed number. I'm going to turn it into an improper fraction to make it easier for us to be able to subtract. So how many eighths are in 10 wholes? Well, that's 10 times 8. That's just 80. Plus this 1/8 that's right here. So that's a total of 81 eighths. All right. So now that I know that I have the same denominators, I'm good to go with subtracting. So I'm subtracting 96 minus 81 eighths. And I can once again go a little bit low and do that math. So 96 minus 81, well, that's going to give me a difference of 15. So we have 15 eighths. Okay. Now we can rewrite this as a mixed number by pulling out the wholes. And so there's enough to make just one whole. And then there will be 7/8 left over. So our answer ends up being 1 7/8. Now, does that make sense based on the work that we did on the number line? Well, let's see. This is 1, and notice that our line stopped closer to the 2, which makes sense because 7/8 is really close to a second whole. So, does it make sense based on the work we did on the number line, our answer that we found? Yes. So, let's answer the question now. How much gasoline is left in the tank? There is 1 7/8 gallons. See, we're counting in gallons of gasoline left in the tank. Okay. Now, let's take a look at problem C. Problem C says a fish was swimming 3½ feet below the water's surface at 7 a.m. 4 hours later, the fish was at a depth that is 5¼ feet below where it was at 7 a.m. What rational number represents the position of the fish with respect to the water's surface at 11 a.m.? So, what is happening here? Well, we're talking about depth. We're talking about water and depth. So, if we're talking about depth, that means how far down in the water the fish is going. Okay. So, that's what we're trying to see. At 7 in the morning, the fish was only 3½ feet below the water's surface. Okay. So, let's draw a picture so that we can see what they mean by this. So I'm going to make some water here. Okay. And I'm going to make us a number line. And our number line is going to represent the depth as we're going lower and lower. And so, and you know what, I'm going to extend this number line maybe above water as well. Okay, so I've got my number line and I've got my water drawn, right? So right here where the water is represents 0, okay? Because that's the surface of the water. Now what they're saying is at 7 a.m., this fish was only at a depth of 3½ feet. So let me start drawing some tick marks here on this number line so we can be able to visualize what they're referring to. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So at 7 a.m., the fish was at 3½ feet. So where is that going to be? 3½ Well, that's somewhere between 3 and 4, right? So here's our little baby fish. And there, little goldfish. All right. So he's about at 3½ And let me kind of zoom in here. So that's our starting point. Okay. And since we're below sea level, or below the surface, then this 3½ is already, this is negative. These should be negative because we're going below the surface. So these are all negative numbers. So this 3½ since it's below, we're saying that that is a negative 3½ And she's going to go further below. It keeps going down. The fish keeps going down further into the water. So it's going further negative. So what does that equation look like? Well, it means that I'm already at negative 3½ And now I'm wanting to go minus 5¼ further. Or what we can think about it as the additive inverse would be 3½ plus negative 5¼ right? So either way, it's still going to give us the same thing. Okay, so we're moving this way down. So I can draw an arrow to go down 5¼ And so what I'm going to do is kind of like guesstimate it right now. So this would be 1, 2, 3, 4. So this is about 5. And so if I'm going 5¼ then I'm estimating that that's going to be about here. So where this fish is, drawing my arrow going down, descending further negative. That's what we're looking at. So this is where the fish was at 7 a.m. And 4 hours later would mean that this is where the fish is at 11 a.m. Okay. All right. So we need to solve for what this is going to be. We are going further negative. So essentially, we're combining these negative numbers together. So we're adding a negative to a negative, making it a smaller negative number or negative rational number at this point. Well, we know that the only way we can be able to add fractions is if they have the same denominator, and the same rules apply even if these are negative fractions or mixed numbers. So what we want to do is take these mixed numbers and we want to make them into an improper fraction. So how many halves are in 3? Well, there are 6 halves in 3 wholes. So we've got 6 halves plus this 1 half right here. So that means that we can rewrite this as a mixed number of negative 7 halves. So there are 6 halves in 3 wholes plus this other half, making 7 halves. All right. Now we're going to rewrite this as a mixed number. Excuse me, this mixed number as an improper fraction. So how many fourths are in 5 wholes? Well, 5 times 4, that'll give us 20. So there are 20 fourths in 5 wholes, plus this one more fourth here. So that makes 21 fourths. That's also negative. Now, the only problem with this is that they still don't have the same denominators. So we're going to change this so that they have the same denominator. Well, how can I make halves into fourths? By multiplying by 2. And if I do that to the bottom, then I also have to do it to the numerator. So that means that this is going to change yet again into negative 14 fourths plus negative 21 fourths. Well, negative plus a negative, that's going to make more negative, right? Because we're going farther down. Negative 14 plus negative 21. Well, we can go off to the side and add those together. 4 plus 1 gives us 5. 1 plus 2 gives us 3, and it's still negative. So that's going to be a negative 35 as our numerator. And of course, we don't add denominators. The denominator just stays the same. So we have negative 35 over 4. Well, we can rewrite this as a mixed number. So how many times can 4 go into 35? Well, 35 is really close to the multiple 32, and 32 is a multiple of 4. So we can say that 4 times 8 makes 32. So I can pull out 8 wholes. And that will leave us with a difference of 3 fourths. So what we're saying here is that negative 35 fourths can be rewritten as a mixed number of negative 8 and 3 fourths. Now, does that match up based on the work we did on the number line? Well, sure. We have our line where we stopped our arrow. It is between negative 8 and negative 9. Also, it's closer to the negative 9. Well, that makes sense because 3 fourths is closer to being one more whole. So now we just need to answer the question. What rational number represents the position of the fish with respect to the water surface at 11 a.m.? The fish is at a depth of 8 3/4 feet, excuse me, below the water's surface at 11 a.m. And there you have it. I hope this was helpful for you. Remember that I'm having office hours tomorrow between 11 and 11:30. So if you need any assistance going through any of the work, feel free to hop on and I'll be there waiting for you. See you guys later.